Welcome to the HESI A2 Test Prep online lesson series. In this lesson, we'll go over the math section of the HESI test. In this video, we'll go over 16 math questions for your HESI A2 test prep. We'll cover simplifying expressions using PEMDAS, simplifying expressions involving signed numbers, and word problems involving addition, subtraction, multiplication, and division. Before we start, make sure you have a pencil and paper so you can take notes and follow along through the problems. Then download the Test Prep app from the App Store or Google Play. It has homework and practice tests to support this lesson. The app also has a prediction test so you know exactly when you're ready to take the real test. Okay, let's get started. So today we're going to be doing a lot of PEMDAS, which we can write out as P-E-M-D-A-S. P stands for parentheses. E stands for exponents, which is this little caret. M stands for multiplication. D is division. A is addition. And S is subtraction. Important to note here that multiplication and division and addition and subtraction are each their own step, which means they happen at the same time from left to right. That means if we see a division first, we're going to do that before multiplication. Similarly, if we see subtraction before addition, we're going to do that subtraction first. Another important note here is that parentheses tell us where to look. Once we're looking inside the parentheses, we're going to start our PEMDAS from the beginning. So we're going to say, is there another set of parentheses? Do we have exponents? Then do we have multiplication and division? Then do we have addition and subtraction? Okay, so let's start on this problem. First, I see two sets of parentheses. I can simplify this first set, 86 minus 36, as 50. And in the second set, notice we have 8 squared, so before we subtract, we're going to need to evaluate 8 squared, which is 64. Okay, now we're going to do 64 minus 46, which is going to be 18. And now let's rewrite everything, having simplified these two sets of parentheses. So now we have 50 divided by 5 squared times 50 plus 3 cubed minus 18. Okay, parentheses are done. Now we're going to look at exponents. Now we have 5 squared and 3 squared. So this is going to be 25, and this is going to be 9. Let's rewrite everything else. Okay, exponents are done. Now we're going to look at multiplication and division from left to right. So see here I have this division sign before the multiplication sign. So even though in PEMDAS it does look like multiplication is going to come first, it's important to remember that multiplication and division happen in the same step. So what really matters is which one comes first when we're looking from left to right. 50 divided by 25 is going to be 2. Let's rewrite everything that we didn't mess with. Okay, now we have 2 times 50. That's going to be 100 plus 9 minus 18. Now 100 plus 9 is going to be 109 minus 18 is going to give us 91. Okay, another PEMDAS problem. So here we have 1/5 times negative 1/2 plus 3/10. So notice we do have those parentheses, but there's no other operation inside of there. So we're going to look at that and we're going to say, okay, nothing needs to be done there. Let's move on. Okay, so we're going to start with 1/5 times negative 1/2. You should remember that when multiplying fractions, we go straight across. So this is going to be 1 times 1, which is 1, and then 5 times 2, which is 10. Okay, and then this 1/5 is positive. The 1/2 is negative. A positive times a negative is going to be negative. Okay, and then let's rewrite that 3/10. So now we have minus 1/10 plus 3/10. Negative 1 plus 3 is going to be 2. Our denominator stays the same. We can reduce this fraction by noting that we can divide the top and the bottom by 2, which gives us 1/5. Now we have 4/7 times 0.5 divided by 8/21. So the first step here is going to be to make these all look the same. Right now we have two fractions and one decimal. So let's turn this decimal into a fraction. We should know that 0.5 is equal to the fraction 1/2. Okay, so I've just rewritten this problem, replacing the 0.5 with 1/2. Now we're going to solve from left to right. So we're going to start with 4/7 times 1/2, multiplying straight across. 4 times 1 is 4. 7 times 2 is 14. Divided by 8/21. When we divide a fraction, we keep the first one. So we're going to keep 4/14. We change the division to multiplication, and we flip the second fraction. So that becomes 21/8. Notice here that we have a 4 in the numerator and 8 in the denominator. So we can divide out of 4. That gives us 1/2. It makes our multiplication just a little bit easier. We have a 21 here and a 14 here, so we can divide out of 7. 21 divided by 7 is going to be 3. 14 divided by 7 is going to be 2. 1 times 3 is 3. 2 times 2 is 4. So our answer is 3/4. Okay, this one's going to be a little bit more complicated. Not necessarily more complicated, just a little longer. Whenever I see a lot of fraction operations like this, I'm going to want to start by turning all of our mixed numbers into improper fractions. So, quick review. If we want to turn 5 1/4 into an improper fraction, we're going to do 5 times 4, which is 20. 20 plus 1 is 21. And then we're going to keep that same denominator. So 5 1/4 equals 21/4. Let's do the same thing for 2 1/3. 2 times 3 is 6, plus 1 is 7. So we have minus 7 on top. Denominator stays the same, that's just 3. Now we're going to add 1/3 times 5 1/2. 5 times 2 is 10. 10 plus 1 is 11, so we have 11/2. And lastly, we have divided by 2 times 2 is 4, plus 1 is 5, divided by 2. So this is what our problem looks like in terms of improper fractions. Now remember PEMDAS. We see that multiplication and division come before addition and subtraction. So we're going to need to start with the first multiplication we see, going from left to right. First we have subtraction, then we have addition, and then we have this multiplication right here. So this is where we're going to start. So I have 21/4 minus 7 over 3. And then we're going to simplify that 1/3 times 11 over 2. 1 times 11 is 11. 3 times 2 is 6. Divided by 5 over 2. Now looking again left to right, we have subtraction, addition, and then division. So we're going to do division first. So 21 over 4 minus 7 over 3 plus, remember, keep the first fraction, 11 over 6, change the division to multiplication, and flip the second fraction. So we have 2 over 5. We can simplify this just a little bit by noticing that 2 and 6 are both divisible by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. Now we multiply across. 11 times 1 is 11. 3 times 5 is 15. So our new fraction is going to be 21 over 4 minus 7 over 3. And then this 11 over 15 is just standing in for 11 over 6 times 2 over 5. So notice we have this addition here, so it's going to be plus 11 over 15. All right, so now we're adding and subtracting, so we're going to need a common denominator. This could be a little bit tricky, so go ahead and pause the video and see if you can come up with a common denominator for 4, 3, and 15. All right, so that common denominator is going to be 60. So we're going to need to turn each of these fractions into 60. How can we turn a 4 into a 60? We need to multiply the top and the bottom by 15. So this is going to be times 15 over 15. How do we turn a 3 into a 60? We need to multiply the top and the bottom by 20 over 20. And then lastly, how do we turn a 15 into a 60? We need to multiply the top and the bottom by 4 over 4. (21) times 15. Let's do that real quick. It's going to be 5, 10, 0, 21. Add them together. 5, 1, 3. So we're going to get 315 over 4. Now we have, 315, and then that's going to be over 60. Over 60. Now we're going to do 7 times 20 is 140. 3 times 20 is 60. Plus 11 times 4 is going to be 44. 15 times 4 again is going to be 60. Now we need to do 315 minus 140. Remember, we're going from left to right. So that's going to be 175 over 60 plus 44 over 60, which is going to be 219 over 60. How many times does 60 go into 219? Well, I know 60 times 4 would be 240, right? Because 6 times 4 is 24. we would add a 0, 240. That's too much, so it's going to be 60 times 3. So our whole number is going to be 3, and that would be 180. The difference between 219 and 180 is going to be 39. So that'll be 39 over 60. You can see we can simplify this by dividing by 3. And that's going to be 3 and 13 over 20. So definitely a longer problem, but not necessarily challenging. Just a lot of steps and a few two-digit multiplication problems in there. $150 times negative 60 minus negative 60 times negative 750. So if we break this problem up, we see that we have multiplication here between these two numbers. We have multiplication here, and those are separated by subtraction. Multiplication comes before subtraction, so we're going to simplify those two chunks, those two sides of the subtraction equation, and then we'll subtract what we get. So we're going to start with 150 times negative 60. We can write that simply as 15 times 6. 5 times 6 is 30. So we get 90, right? And then there was actually a 0 here and a 0 here. So we're going to add 2 zeros, and that's 9,000, right? And then that was positive 150 times negative 60. Positive times a negative is going to be negative. So this whole left side here evaluates to negative 9,000. Now let's do the right side. We have negative 60 times negative 750. Let's ignore the zeros. So we'll just do 75 times 6. 5 times 6 is 30. 7 times 6 is 42, plus 3, 45. This was actually 750, so there was a 0 here. This was 60, so there was a 0 here. Let's add those two to our answer. And then notice it was minus 750 and minus 60. Minus times a minus is a plus. Right? So the right side of our subtraction problem is equivalent to positive 45,000. So let's rewrite this as negative 9,000, this guy, minus 45,000, which was this guy. Right? So we're doing minus 9,000 minus 45,000. The way I like to think about these is a negative means we're stepping backwards, a positive means we're stepping forwards. So we're stepping backwards 9,000 and then backwards again 45,000. So in total, we're going to step back 54,000. So it's like, in a way, we're adding 9,000 and 45,000 to get 54,000. That's all negative because we were working in negatives. Now we have 7 squared times 2 to the 5th minus 32 over 2 squared. So remember PEMDAS, we're always going to start by evaluating inside the parentheses first, which is going to be inside right here. Right? And then once we're looking inside of our parentheses, what's next is going to be that exponent, this guy right here. What's 2 to the 5th? That's going to be 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. This is 4 times 4 times 2. 4 times 4 is 16. Times 2 equals 32. So 2 to the 5th is just 32. So we have 32 minus 32 divided by 2 squared. Now notice 32 minus 32 is just going to be 0, right? And then 7 squared, it doesn't even matter what 7 squared is because we're multiplying it by 0. Anything times 0 is 0. So that's going to be 0 over 2 squared. And we know 2 squared is 4, but again, that doesn't matter because anytime we have a 0 in the numerator, our fraction is just equal to 0, regardless of what our denominator is. So our answer is 0. Okay, another longer problem, but not necessarily challenging. So we're going to look inside our parentheses. Our first set of parentheses is going to be this guy, this whole outside guy. So that's what we're looking at first. And then we're going to say, oh, inside that parentheses, we have another parentheses, right? Because each time we look in our parentheses, we restart PEMDAS. So we're working on these parentheses first. So we're going to need to do 6 times 1.45. I'm going to write this like this, put this 1.45 on top, 6 on the bottom. We'll ignore the decimal for now. 5 times 6 is 30. 4 times 6 is 24, plus 3 is 27. 1 times 6 is 6, plus 2 is 8. Okay, and now we had 2 numbers to the right of the decimal place, the 4 and the 5 right here, which means we're going to move this decimal, this invisible decimal, 2 places to the left, so this answer is 8.7. Now let's do 5 times 2.95. Again, I'm going to put the 2.95 on top, just because it makes my multiplication a little bit easier. I don't have to write a whole bunch of zeros. Five times 5 is 25. 9 times 5 is 45, plus 2 is 47. 2 times 5 is 10, plus 4, 14. Now notice we had 2 numbers to the right of the decimal place, which means this decimal right here is going to move 2 places to the left. So this is just 14.75. Let's rewrite this. We have 8.7. I'm going to leave off that 0 because a 0 at the end of a decimal doesn't change anything. You could put 0, 0, 0, 0, 0, 0. Those are all empty, so it's not going to add anything to our problem. 5 times 2.95 was 14.75 plus 12.95. All of that was times 1.08. So now we're going to need to add those. We're going to do that by lining up our decimals. The order doesn't really matter, but I'm going to start with 12.95. 14.75, and lastly 8.7. So pay very close attention. Make sure that your decimals are all lined up in a row, just like this. 5 plus 5 is going to be 10. 0, 1. 1 plus 9 is 10. 10 plus 7 is 17. 17 plus 7 is 24. Carry the 2. 2 plus 2 is 4, 4 plus 4 is 8, 8 plus 8 is 16, carry the 1, 1 plus 1 plus 1 is 3. And then, so this is what was inside of that parentheses. Now we have to multiply by 1.08. It's going to be our last step. 36.4, I'll leave off the 0, and I'll write out 1.08. So for multiplication, it doesn't matter if we line them up. Actually, we're not going to line them up. We deal with the decimals at the very end like we did earlier, just by counting the number of places to the right of the decimal, and we use that to move our decimal and our final answer to the left. So 4 times 8 is 32. 6 times 8 is 48. Plus 3 is 51. 3 times 8 is 24, plus 5 is 29. We're done with the 8. Okay, we'd have a 0 here, and then we have a 0 right in this middle column, so we're just going to get a bunch of zeros, right? 0, 0, 0. We're done with that. And because we're now in our third place, we're going to add 2 zeros, and then we're going to do 4 times 1 is 4, 6 times 1 is 6, 3 times 1 is 3. Add these all up. 2, 1, 9 plus 4, 13. 1 plus 2 is 3, plus 6 is 9. Bring down the 3. All right, and then we had this 4 was to the right of the decimal. And then we had a 0 to the right of the decimal and an 8 to the right of the decimal, which means we move our decimal 3 places to the left. 39.312. And then another important reason we drop off that 0, so like see this 0 right here, is if there was a 0 here, we would have ignored it when we're counting the numbers to the right of the decimal, because again, a 0 means nothing, right? Because I could have 0, 0, 0, 0, 0. These are not going to change the problem at all, because there's nothing there. Those are just empty spaces. That's a 0 in the hundredths place, 0 thousandths, 0 ten thousandths, all of those mean nothing. So whenever you have a 0 at the very end of the numbers to the right of the decimal, just drop it off. Just get rid of it. A marathon runner completes a race in 2 hours and 40 minutes. If the runner maintains a constant pace and covers 2 miles every 20 minutes, how far does the runner run in the race? So this is the important part, right? 2 miles every 20 minutes. That's our pace, and then the total amount of time we're running is going to be 2 hours and 40 minutes. So how many times does 20 minutes fit inside of 2 hours and 40 minutes? That's our question. How many 20-minute intervals fit inside of that 2 hours and 40 minutes? So 20 minutes fits inside an hour 3 times, right? Because 20 times 3 is 60. 60 minutes is an hour. We have 2 full hours, so that's going to be 3 20-minute intervals times 2 hours equals 6 intervals. Don't worry too much about this word intervals here. We're really just saying how many times does 20 minutes fit inside of 2 hours and 40 minutes. And then we have an extra 40 minutes, right? That's 2 20-minute intervals. So plus 2 intervals. So we have a total of 8 20-minute intervals. In each one of these intervals, we're running 2 miles, right? That's the second part of the problem. So all we're going to do here is 8 intervals times 2 miles for each interval equals 16 miles. Isaac had 7.5 packs of smoked bologna sausages. He cooked 4 3/5 packs for a party. How many sausage packs does he have left? So we started with 7.5. We used, which means we got rid of 4 3/5. We're asking how many are left. So addition and subtraction. Let's turn these into improper fractions. 7 times 2, 14. 14 plus 1, 15. 15 over 2. 4 times 5 is 20. 20 plus 3 is 23. So minus 23 fifths. Now we need to turn these into, we need to get these to a common denominator so we can subtract. Common denominator between 2 and 5 is going to be 10. So let's multiply this first fraction by 5 over 5. Multiply the second fraction by 2 over 2. 5 times 15 is going to be 75. 2 times 5 is 10. 23 times 2 is 46. 5 times 2 is again 10. $75 minus 46 is going to equal 29 over 10. We have an improper fraction. Let's turn that back into a mixed number. So 10 goes into 29 twice, with 9 left over. Denominator stays the same, so our answer is 2 and 9/10. Henry drank 3 3/4 glasses of strawberry limeade while his sister drank 1 1/2 glasses. How many more glasses did Henry drink than his sister? So, similar problem. We're comparing 3 3/4 to 1 1/2, and we want to know the difference, right? We're asking who drank more, so we want to know the difference, which means subtraction. So we're going to do 3 3/4 minus 1 1/2. We'll start by turning those into improper fractions. 3 times 4 is 12 plus 3. 15 over 4 minus 1 times 2 is 2. 2 plus 1 is 3. 3 over 2. What's the common denominator between 4 and 2? That's going to be 4. We'll multiply this by 2 over 2. So we have 15 over 4 minus 3 times 2 is 6. 2 times 2 is 4. 15 minus 6 is 9. Denominator stays the same. And then we turn this back into a mixed number. 4 goes into 9 twice, with 1 remainder, and our denominator stays the same. So our answer is 2 and 1/4. Julian was asked to type 28 1/2 pages in 3 days. She finished typing 11 pages on the first day and 9 3/4 of a page on the second day. How many pages did she need to type on the third day? So the total amount of pages that need to be typed is this 28 1/2. So far we've already typed 11 pages on one day and 9 3/4 page on the second day. We want to find out how much more we have. So let's find out how many pages we've typed so far. That's going to be 11 plus 9 3/4. So notice there's no fraction accompanying that 11. So very simple here, we can just add 11 and 9. Add our whole numbers together. That's going to be 20 3/4. And then we needed to type 28 1/2 pages. So let's find the difference to find how much more we have to go. So we have 28 1/2 minus 20 3/4. We need to turn those into improper fractions. Then we're also going to need to get a common denominator. 28 times 2 is 56. 56 plus 1 will be 57 over 2 minus 20 times 4 will be 80. 80 plus 3 will be 83. Right. Once again, we have 2 and 4 as our denominators. We need to get a common denominator, which is just going to be 4. So we'll do 2 over 2, multiply by 2 over 2. This is going to be 114 over 4 minus 83 over 4. which would give us 31 over 4. If you need to stack those to subtract, you can definitely do that. I just did it in my head, so we have 31 over 4. 4 goes into 31 7 times. 7 times 4 is 28, which means we have 3 left over. Denominator stays the same, so 7 3/4 of a page left. If Mike can type 3 3/4 of a page in 45 minutes, how many same pages can he type in 1.5 hours? We know 1 hour is 60 minutes. We know half of an hour, so that's 0.5 is 30 minutes. So 1.5 hours equals 90 minutes. So notice we have 45 minutes. We have 3 3/4 of a page in 45 minutes. And they're asking about 90 minutes. Well, we know that 45 times 2 equals 90. So in 90 minutes, we're going to type double what we type in 45 minutes because it's twice as much time. So we're just doing 3 3/4 times 2. 3 times 4 is 12, plus 3 is 15. 15 over 4 times 2 equals 30 over 4. Remember, if we have a fraction times a whole number, that whole number just multiplies to the numerator, only to the numerator. 30 over 4 can divide out 2's. So we have 15 over 2. 2 goes into 15 7 times with 1 left over. So our answer is 7.5. Postage on parcel A is 60 cents and postage on parcel B is 3/5 of A. What is the total postage on both parcels? So parcel A, 60 cents. Parcel B, 3/5 of A. Remember, of means multiplication. So if we want to find the cost of parcel B, we're going to do 3/5 times A, which was 60. Again, multiplying a whole number by a fraction, the whole number multiplies by the numerator only. So this becomes 180 over 5, which is going to be 36. You could long divide, or you could just say 5 goes into 10 twice, and then 10 goes into 180 18 times. So it's 2 times 18. There's a couple ways you could do that, whatever works for you. So 2 times 18 is going to be 36. So that's the cost of parcel B. The cost of parcel A was 60 cents. They're asking about the cost of both parcels, so that's going to be 60 plus 36, which equals 96 cents. A man bought a pair of jeans for $23, a shirt for $14.95, and 3 ties for $7.98 each. What was the total cost of his clothing? Okay, so we have 23. Again, notice that these are zeros here to the right of my decimal, just hanging out there. So I'm going to ignore those. 23, we have a shirt for $14.95. And then read very carefully here, we have 3 ties for $7.98 each. So that's going to be plus 3 times $7.98. Right, order of operations here, we have 3 times 7.98. So we're going to do that first. There's a couple ways you could do this. The typical way, what we've been doing, would just be to stack them and do 798 times 3. But 798 is really close to 8. So I know that 3 times 8 is going to be 24. And then for each of those, we're 2 cents short. So we're short 2 cents 3 times. So that's going to be 24 minus 6 cents, which is going to be 23.94. Right? If that was a little bit hard to follow, don't worry. Just go ahead and multiply those how we've been by stacking. But this is another good trick to add to your toolkit, your math toolkit. So we have 23 plus 1495 plus 2394. Now we'll line up our decimals and add. So we have 23, right? The decimal would be here, but there's nothing to the right. Then we have 14.95 and 23.94. Be very careful how you line up all your columns here. And then we're going to go from right to left. 5 plus 4 is 9. 9 plus 9 is 18. Carry the 1. 1 plus 3 is 4. 4 plus 4 is 8. 8 plus 3 is 11. Carry your 1. 1 plus 2 is 3. 3 plus 1 is 4. 4 plus 2 is 6. So 61.89. Question 15. A group of friends decided to play soccer for 4 hours this week. They played for 1¼ hours on Saturday and 45 minutes on Sunday. Write an expression for the situation. How many more hours do they need to play this week? So another situation where we have hours here and we have minutes here. So we're going to either change the hours to minutes or the minutes to hours. Either will work. I'm going to change the minutes to hours. So 45 minutes, and then there's 60 minutes in an hour, right? So we're going to divide by 60. 45 divided by 60. We can divide out 15. So we're doing divided by 15, divided by 15. 45 divided by 15 equals 3. 60 divided by 15 equals 4. So that 45 minutes is the same as saying 3/4 of an hour, which you might have guessed before we started solving. So to find the total amount that we've played so far, we're going to do 1 1/4 plus 3/4. Okay. So we could add, or we could turn that 1 1/4 into a improper fraction, and then add them together, and then turn it back into a mixed number, which is what we've been doing. Or we could just note that 1/4 plus 3/4 is going to make 1. So if we add those fractions together, we're going to make 1, and then we already have this 1 here, so 1 plus 1 is 2. Right? It's like saying 1 hour and 15 minutes plus 45 minutes, 2 hours. And now we wanted to play for a total of 4 hours. We've played so far for 2 hours. So how much more do we need to play? We're going to do 4 minus 2 equals 2. A telecommunications company receives 4,500 customer support calls per day. If each call has an average duration of 12 minutes, how many hours of support calls does the company handle in a week? So, super important here. Notice that the question is asking about a week, but the number of calls up here, 4,500, is for a day. So at the end of this problem, we're going to need to multiply by 7 to get the total number of calls for the entire week. All right, so 4,500 calls per day. Each call is 12 minutes. So let's find the total amount of minutes per day by doing 4,500 times 12. Right, and then to do that, I'm going to do 45 and 12. Ignoring the zeros. 5 times 2 is 10, carry the 1. 4 times 2 is 8, plus 1 is 9. Add a 0 down here, and then 5 times 1 is 5. 4 times 1 is 4. Add them together, 0, 4, 1, 5. So 540, and then this was actually 4,500. We had 2 more zeros here, so we're going to add 2 more zeros here. So we have 54,000 minutes of calls per day. The question is also asking about hours, right? How many hours of support calls? So this is in minutes. If we want to turn minutes into hours, we're going to need to divide by 60. So let's do 54,000 divided by 60. If we have a 0 in the numerator and a 0 in the denominator, we can cancel those out, right? That's the same as dividing out by 10. So really this is 5,400 divided by 6. And then what's 54 divided by 6? 54 divided by 6 is 9, right? But it was 5,400. We had 2 more zeros, so add your zeros here. So 900. So 900 hours per day. So if we want to know how many hours per week, we need to do that 900 hours per day times 7 days. 9 times 7 is 63. And then account for these 2 zeros here. 0, 0. So that's going to be 6,300. Once again, don't forget to download the HESI Test Prep app from the App Store or Google Play, where you'll find homework and practice tests for this lesson. Make sure you score at least 80% on the practice test before moving on to the next lesson. I hope this was helpful. Thank you, and I'll see you next time.